1 0 0, right? So you can see minus 1 1 0 0, right? Now we are multiplying first row with minus 2 and add into the third row. That is our next step. So let's see that is correct or not. 2 minus 2 0, then 4 minus 4 0, 3 minus 6 minus 3, and 3 minus 2 1. So 0 0 minus 3 1, right? Now 0 minus 2 minus 2, 0 minus 0 0, 1 minus 0 1, and this is 0. So minus 2 0 1 0, minus 2 0 1 0 here, right? Now also next step is we are multiplying first row with minus 1 and add into the fourth row. So 1 minus 1 0, then 1 minus 2 minus 1, then 1 minus 3 minus 2, 1 minus 1, this is 0. So 0 minus 1 minus 2 0, 0 minus 1 minus 2 0, you can see here 0 minus 1 minus 2 0, and then 0 minus 1 minus 1, 0 minus 0 0, this is also 0, and 1 minus 0 1. So minus 1 0 0 1. Okay, so the one step is complete, that this is our leading, this is our 1. Below that element we have now all the 0 in that particular column. Now don't forget our main aim, that is we have to convert, using row operations, we have to convert this identity matrix into the left hand side. Okay, so still we have lots of work to do, because only the first column is correct now. Other or all columns are, you can see this is at all not an identity matrix. So now in the second row this is our leading entry. Now below that leading entry we have 0, and above that leading entry also we want 0. So below that leading entry in the third column we have already 0. Third row, sorry, in the third row below that leading entry we have 0, but next step is we are multiplying second row with 1 and add into the fourth row, and multiplying second row with minus 2 and add into the first row. So the third row is as it is, 0 0 minus 3 1 minus 2 0 1 0, and then 0 0 minus 2 1. Just we have to add second and fourth row and add into the all elements in fourth row, right? So 0 plus 0 0, 1 minus 1 0, this is 0 minus 2 minus 2, 1 plus 0 1, minus 1 minus 1 minus 2, then 1 plus 0 1, and then 0 plus 0 0, 0 plus 1 1, right? Now next is we are multiplying second row with minus 2 and add into the first row. So that is 1 0 3. We are multiplying second row with minus 2. So minus 1 minus 2 plus 1 minus 1, then 2 plus 1 3, then 2 plus 0, right, minus 2 plus 0 minus 2, and 0, and then 0. So now 1 0 3 minus 1 3 minus 3 0 0, and all other rows are as it is, 0 1 0 1 minus 1 1 0 0. The third row is now 0 0 minus 3 1 minus 2 0 1 0, and the fourth row is 0 0 minus 2 1 minus 2 1 0 1. Now what is our next process? In the first column we have first element is 1, below that 1 we have 0. In the second column second number is 1, all other are 0. Now in the third column, first of all we want 0 here, right? So that's why our next process is we are multiplying third row with minus 1 by 3. So you can see multiplying third row R3 with minus 1 by 3. So that's this element become 1 now. Okay, and that is necessary for us because we want to convert a identity matrix. So in identity matrix all the diagonal elements must be 1, all the principal diagonal element must be 1. So that's why we have to multiplying this third row with minus 1 by 3. So this third row become, you can see 0 0 1, then minus 1 by 3, 2 by 3 0, minus 1 by 3 0, 2 by 3 0, minus 1 by 3 0, correct. So this third row is now changed, that is 0 0 1, minus 1 by 3, 2 by 3 0, minus 1 by 3 0. Now all other row are as it is. The first row is 1 0 3 minus 1, 3 minus 2 0 0, 0 1 0 1, minus 1 1 0 0, and the last row is 0 0 minus 2 1, minus 2 1 0 1. Okay, all other row are as it is. Now this element is now 1. So next process is we want make 0 in that column except this 1. So here is not 0 and here is not 0. So that's why we are multiplying third row with 2 and add into the fourth row, and also multiplying third row with minus 3 and add into the first row. So 0 0 0, then minus 2 by 3 plus 1, minus, we are multiplying third row with 2. So minus 2 by 3 plus 1, so that is 1 by 3, minus 2 by 3 plus 1, that will become 1 by 3. Then we are multiplying third row with 2 and add into the fourth row. So the 4 by 3 minus 2, that is 4 minus 6 by 3, that will become minus 2 by 3. Then okay, each and every element you have to understand that how it's coming from the which step. So third row with 2 and add into the fourth row, so that will become 1 as it is. Then minus 2 by 3 plus 0, minus 2 by 3, and then this become 1, right. Now also we are multiplying third row here with minus 3 and add into the first row. So the first row is 1 0 0, then minus 1 plus 1, that will become 0. Okay, and then 3, we are multiplying third row with minus 3 and add into the first row. So that will become 3 into, you can see 3 minus 2, so 1, then minus 2 plus 1, minus 2 plus 0 into minus 3, so that will become minus 2. Here 0 plus minus 3 into minus 1 by 3, so that will become 1. So right here 1 and then 0, correct. So now you can see still the fourth column is not right as far as our opinion, because we need identity matrix. So the first column is correct, right, this is 1 0 0 0. The second column is also now right, 0 1 0 0. So third column is also correct, 0 0 1 0, but the fourth column here we need 0 0 0 1. So again we have to multiplying fourth row with 3, right. So that is our next process. We are multiplying fourth row with 3. So the fourth row becomes 0 0 0 1, minus 2 1, minus 2 3, minus 2 3, minus 2 3, minus 2 3. Other row are as it is, 1 0 0, minus 2 1, minus 2 1 0, right, 0 1 0 1, minus 1 1 0 0, and this is 0 0 1, minus 1 by 3, 2 by 3 0, minus 1 by 3 0. Now we are multiplying fourth row with 1 by 3 and add into the third row, and also multiplying fourth row with -1 and add into the second row, and also multiplying fourth row with 2 and add into the first row. So now we have left hand side identity matrix and other elements are this one. You can see when we multiplying fourth row with 1 by 3, so this will become -2 by 3 plus 2 by 3, so that is 0. Then 3 into 1 by 3, that is 1 plus 0 1, -2 into 1 by 3, -2 by 3 minus 1 by 3, so -3 divided by 3 become -1. Then 3 into 1 by 3 plus 0, so that is 1, right. So this elements are now 0 1 -1 1. Then also we are multiplying fourth row with -1 and add into the second row, so -1 plus 2 1, then 1 minus 3 -2, then 0 plus 2 2, 0 minus 3 -3, also 1 minus 2. Also we are multiplying fourth row with 2 and add into the first row, so the first row is 2 minus, right. So multiplying fourth row with 2, so -4. Okay, we are multiplying last row, fourth row with 2 and add into the first row, right. So that's why this elements become -4 plus 1, that is 1, then 6 minus 2, okay, -2 1 and then 0. So the right hand side, that is our inverse, and that is exactly 1 minus 2 1 0, right. 1 minus 2 2 minus 3 and 0 1 minus 1 1 minus 2 3 minus 2 3. So now using this Gauss Jordan method, here we find inverse of this 4 cross 4 matrix. So let's see, this question was complete now, asked in 5 marks. Let's see the next question. Question 2c, express this matrix 4 plus 2i 7 3 minus I. Here we have 3 cross 3 matrix, right. You can see some of the elements are real numbers and some of the elements are complex number. So this is a complex matrix, 4 plus 2i 7 3 minus I 0 3i minus 2, 5 plus 3i is -7 plus I 9 plus 6i as the sum of Hermitian and skew Hermitian matrix, right. This question was asked in 4 marks. Here is the solution, that A is equal to 4 plus 2i 7 3 minus I 0 3i minus 2, 5 plus 3i -7 plus I 9 plus 6i. Now we have to convert. Now there is one important result, that we know that for any matrix it can be expressed as sum of Hermitian and skew Hermitian matrix, right. How? A is equal to always A plus A star divided by 2 plus A minus A star divided by 2. So we know that for any square matrix, A can be expressed as A is equal to A plus A star plus A minus A star divided by 2, where this A plus A star. Now first of all, just try to understand what is A star. That is exactly the transpose of the conjugate matrix, right. Transpose of A bar. A bar means conjugate. So A bar means in complex matrix, if in any matrix there are complex numbers, so we have to that complex number write down, we have to all the elements are conjugate of that complex number, right, and then we have to transpose. So that is exactly our A star. So here is one important result, that we for any square matrix A can be always expressed as A plus A star divided by 2 plus A minus A star divided by 2. And the main important thing is that A plus A star divided by 2, that is always Hermitian matrix, and A minus A star divided by 2, that is always skew Hermitian matrix. That we can easily prove, okay, by the definition. Using the definition, we know that definition of Hermitian matrix means if A is a Hermitian, if A star is equal to A, and if A is a skew Hermitian matrix, then A star is equal to minus A. Okay, so we can easily prove that this A plus A star, the star of A plus A star, that is equal to A plus A star. You can see, because we know that A star plus star of A star, that is A plus A star. So easily we can prove that this A plus A star divided by 2 is a Hermitian matrix, and this A minus A star divided by 2, that is a skew Hermitian matrix. Okay, so in particular for this matrix we have to write down as a sum of Hermitian and skew Hermitian matrix. So first of all we find this A plus A star divided by 2, then we find A minus A star divided by 2, and then definitely we can write down as a sum of this Hermitian and skew Hermitian matrix. Okay, so let's see, this is our matrix A, right? 4 plus 2i, 7, 3 minus I, 0, 3i, minus 2, 5 plus 3i, minus 7 plus I, 9 plus 6i. Now this is A star. A star is 4 minus 2i, the complex number. You can see we have to write down all the complex conjugate of all the number. You can see, instead of 4 plus 2i, we have to write down 4 minus 2i, then 7. Instead of 3 minus I, just change the sign of the coefficient of I, right? Change the sign of the coefficient of I. So that is, instead of 3 plus I, we have to write down 3 minus I, then 0 is as it is, this 3i become minus 3i, then minus 2, 5 minus 3i, minus 7 minus I, right? The conjugate of all this complex number, I said here, conjugate of all this complex number. So instead of 5 plus 3i, it will become 5 minus 3i, then minus 7 minus I, and then 9 minus 6i. So this is our A star. Now we write down here A plus A star divided by 2, right? Now what is A plus A star? You can see, what is in A, we have 4 plus 2i, right? And this is 4 minus 2i. So when we add